Thank you very much. Would you like to take a seat? Yes, that would be great. Very insightful. Thank you. I look forward to the questions on that subject. Let's see. We now move on to assurance in maritime autonomy. It's a sector where Britain is once again at the forefront of global development. And we've got Andre Burgess from MPL, Ben Keith from Fraser Nash, and Thomas Howe and Will Alexander to lead us through this exciting new field of maritime operations. Now, Andre is up first. Andre, over to you.
Thank you very much indeed. Thank you to the last speaker as well, because they've done a very good intro for me in terms of some of the regulatory challenges, and indeed saves me having to talk about it quite so much from a point of view of autonomy. I'd also like to thank the SMI. It's been a really good conference from my perspective. I'm a bit of a land lover, so I'm learning a lot at this one, but also had some fantastic conversations with people. So I'm here today. I've got a very exciting title for you, Assuring the Successful Deployment of Maritime Autonomous Systems. I will try and keep you awake over the next, have I got 15 minutes? Is that right? I will try and avoid yellow and red cards on this. And I'm going to talk a bit about a data-driven approach, so in essence looking at some new approaches to how we assure these systems, and they are very novel systems. And I think one of the key things we've been looking at for the last couple of years with this, with a lot of other organisations, it's not just a sort of NPL-centric thing, is very much this sort of this challenge of what are we trying to demonstrate here? We're trying to demonstrate several things: safety, reliability, and also effectiveness of the system. So there's no point in having a system which doesn't do what it says on the tin. And I think the other part is not focusing on the technology, but focusing on the outcome. So hopefully these slides will give you a very, very shallow dive on some of the work that we're doing in partnership with a range of other organisations. So just briefly about MPL, I know some of you know who we are, National Physical Laboratory. We are the UK's National Metrology Institute, and in that respect, we manage the measurement standards and do a whole huge amount of research and science related to metrology. We have a lot of, about 1,000 scientific experts, 400 laboratories, mostly based in Teddington, but increasingly going around the country, and indeed now we're in discussion about some international activities. We are a very international organisation because we're linked into all the NMIs around the world, because we obviously, when you're developing measurement standards, you have to do that internationally. A couple of other things is, obviously, we're now owned by DSIT. We were owned by Bayes. And one of our missions, if you like, and it's an area where I'm very focused on, is how we use our measurement science and our research to provide confidence to organizations or sectors, et cetera, for the adoption of future technologies. And that's very much what we're going to talk about today. Firstly, when we talk about opportunity before we talk about challenge, one of the things that we've been looking at, and we do actually look at it in terms of a national resilience question as well, is it's not about a single piece of autonomy or a single vessel or a single vehicle. We look at the whole system in the UK and say, how much is autonomy going to be adopted, and what are the risks inherent in that? And one of the challenges that we've identified is the need in the UK to have an appropriate test and certification infrastructure for autonomy. And if you think about this, if you're looking at a couple of vessels out in the water, so long as they're not massive things in a smart port environment, you're probably not looking at too much risk. But it's more about if you suddenly find that 30% of all your activity is actually done by automated or autonomous systems, systems where humans are not really in the loop, what kind of risk do you have there? It's not just a cyber risk. It's also not necessarily being able to understand where things might fail unintentionally, or they've hit an edge case which wasn't anticipated. So this is very much about developing that capability, but then you turn that on its head and it turns into an opportunity as well. And talk about some of those opportunities very quickly. Just listening yesterday about offshore renewables, it's pretty clear that there's going to be a significant role for autonomy. That needs to be properly defined, I would say, but certainly listening to the talks yesterday, there's going to be a role for that. And how's it going to be deployed? What needs to be in place in terms of deploying that technology as we roll out a huge amount of more offshore renewables? But also other areas, and again, this needs to be understood better, so it's not just a matter of hyping up the technology. How does this feature in things like decarbonisation of fleets? How does it feature in things like fisheries management, improving the economic output from fisheries and aquaculture, et cetera, port operations, but also maritime security and naval logistics as well. These are all topics where we've been engaged or with our partners have been engaged on. So we know that this is being looked at. And again, I come back to think about this at scale. Don't think about this as a single system. And that's really where we're trying to focus on the assurance and also that operational side of it. So the challenge we're dealing with here is, and I'll go on a bit more in my next couple of slides about this, is the current setup for how these systems are tested, how they're assured, and the whole regulatory environment is not necessarily complete, or not, I hate to use the word not fit for purpose, that sounds very critical, but essentially it's not, because again, it's been built around a sort of a historical approach where humans are very much at the center, the competent and capable person, very much at the center of things. And if we don't have the right capacity in place to do this assurance, this testing, essentially we're not going to be able to take advantage of these systems properly. It'll be less cost effective, more costly to deploy. Do we really get the benefits out of it? So talk a little bit more about the challenge first. One of the first things, this is a very international space. I think obviously you all know that because you work in this sector, but therefore you need to address the question of assurance internationally. So a large part of what we do and our partners do is focus outwards from the UK to understand, A, what's going on and find collaboration. Secondly, already referenced this, but the competent, capable person is very much at the center of things. And if you're taking that out, where does that leave your regulations, your rules, etc.? Thirdly, we're dealing with a very diverse range of systems. I work across land, sea, and air, and sea definitely has the most diverse range of potential uses of autonomy and designs of autonomous systems. And fourthly, just the whole legislative challenge here. So again, legislation's been built over, in this case, hundreds of years, potentially the rules and regulations, and it's been built with the human at the center. You take the human out of that, or rather you're focusing on autonomy. Just rewriting legislation is very hard. I've already witnessed that in sectors such as the self-driving vehicle space. It's very, very hard. And the risk there is it potentially, in an effort to oversimplify your results in that legislation, you might make it harder for companies to deploy systems. So there's a risk there as well. And now, so when we're thinking about what we're trying to achieve here, which is how do we get these systems out reliably, safely, and effectively at scale, we need to look at what kind of new features do we need to have in any sort of assurance or testing or regulatory environment. And there are some underlying principles that we've been looking at. There are more that will come out in the mix as we go forward. And I would also like to have a little caveat at this point is that some of you might be saying, oh, I haven't mentioned this or I haven't mentioned that. That's simply because I've only got, well, probably about 10 minutes now left to speak. So a lot more could go into these slides, but there's a limit to what I can say. 4 of the principles we're looking at, firstly, proportional. So not one size fits all. How you assure something that's very large, very valuable in a complex environment is going to be different to something very small that may be out to sea, etc. So proportionality is very important. Also, the work we do must be underpinned by the development of the new and appropriate standards. Also, we need a proper definition of what does safe look like, and that must feature in the safety argument. And finally, understanding where responsibility lies, and understanding it's probably not just with one organisation, but also not pushing it down or deferring it down a chain of people. And another part to this, sorry, this is, I hope you can read it from here. This, the solution around assurance is very much a multi-themed, multi-layered approach. It must look at a range of different activities. So, for example, you're looking across infrastructure, skills and training, the human factors, as well as the different types of testing environments and testing approaches you need to take. Also, how do you address cyber safe and secure? All those things must be considered going forward in how you develop your assurance solution, particularly when you're looking at it from an operational perspective. And that does require a wide and diverse range of disciplines and functions to be involved. So some of you might have heard about this before. We've been working with a range of partners, particularly Lloyd's Register, on the development of the Maritime Autonomy Assurance Testbed, or MAT for short, and it is a program. I think that previous slide emphasizes is a very programmatic activity. And our objective, in that first line, I'll read it out, it's to enable the fastest adoption of technology, making autonomy affordable and business viable. Results in an accelerated increased realization of benefits of earlier adoption of the technology. It's very much focused on the outcomes and the impacts there. As I said, MAT is something that's come together over the last 18 months. It's very much focused on the development of a combined cyber-physical testbed, very much a world first in its approach, we believe, but also an operational certification framework. Those two bits working together, working hand in hand. I'll come on to this in a moment, but it's based out of the Plymouth and South Devon Free Zone, but it is very much networked as well, and I'll explain that a bit more in the next slide. So going on to this, so we're starting out in Plymouth. They have a lot of very good capabilities there, but there are a lot of very good capabilities around the country. So this is very much being developed as a national capability. We're starting out in the Plymouth Smart Sound, and what we're doing is going to be developing that as a fully digitized test bed and operating environment. A key thing we're looking to do there is understand how we actually qualify the ground truth in the digital space, because that's a real challenge. That's something that you'll need very much in terms of your operational assurance, understanding why things went wrong, etc. But it's also going to follow, in doing that, it's following an evidence-based approach, how we standardize tests, methodologies, but also are able to report and adopt best practices. And one of the things we're also doing, and this is working with other sectors, so we work through Department for Transport into other sectors and understand where other regulators are. We've done a lot of work in, as I said, in self-driving and aviation as well, and to understand where there are things we can learn from each other in this space. Now, talking about the network capability, a really important part of this is looking at how we link this across the country and enable different parts, different ports, different parts of the country, different parts of the coastal ecosystem to be able to develop and operate in an assured fashion as well. So that's going to be a key component. We're starting in Plymouth, but actually the idea is to build something that makes the UK hopefully something of a leader in this space. Now, what do we mean by leadership? That could be we're leaders in assurance, but hopefully what it means actually, we can build greater confidence in how we develop these systems and operate these systems, and potentially that can lead to greater opportunities to trade overseas with that as well. How long have I got?
Keep going.
Okay, fine. All right, good. Always good to hear that. Keeping people awake, that's great. So I mentioned that the data-driven approach, and what I'm going to talk about, and I'll try not to make this complicated, because it can very easily, very quickly get quite complex, and there's a lot of material here potentially. And what we mean by this data-centric approach is how we're interlinking different novel techniques that are in development to build on top of what there is at the moment as well. And also, you'll hear from the two following presentations, they'll go into some more depth in some areas of this as well. I won't steal their thunder, so I won't say what they're going to be, but hopefully they'll be, what I'm presenting here will link very nicely into what they're talking about as well. So for starters, and this is something that is quite novel, I suspect most of you will not have come across, as some of you might have, because it is quite novel. But this is something that has been developed both nationally and is being adopted internationally, firstly for self-driving vehicles, but it's now being explored for aviation and maritime. Part of what we're looking to do with MAT is integrated into this. It's known as an operational design domain, or ODD-driven approach, and the operational design domain is the specification of your system to operate in a certain operating domain. So the operating domain is the features of the domain you're in, whether it's the weather, the water state, whether it's a port environment, etc., and a lot more detail around that and the types of third-party systems it can operate around, etc. And then the design part of that is actually your evidencing that it's actually designed to be able to operate in those conditions. Now, this approach is being developed by Warwick Manufacturing Group, and as I said, it's already being adopted at the UN level for self-driving vehicles. So it's something that we're now exploring in terms of a future cross-domain approach for assurance. And as it says in the title, it follows this principle of establishing and measuring true capabilities and limitations of the system. So, and perhaps the key component of this is it's not constrained by existing human-centric regulatory frameworks. So it is something very novel. And it looks at three pillars. The first and most important one, and probably the one we've been most focused on so far, and is focused on for Matt, is performance. And that essentially involves a combination of theoretical evidence, simulation-based evidence, and real-world testing evidence. So you have to create the right test scenarios and then test it, and that builds your safety evidence and your safety argument. There are two other pillars which you might be a bit more familiar with. They're part of the management system. That's around process. That's the process of how you've designed and developed your test regime and your system indeed. And then usage is actually the evaluation and evidencing of the quality of the organization which is running these tests or has developed the system, or both. And that's very important. some of these further slides will sort of link back to that as well, to some degree. So again, I suspect you probably have come across this issue quite a lot, but developing common definitions and understanding are really important. We've been doing a lot of work and engagement internationally, and one of the first things we have to do is work out sort of what we mean by words that we just assumed everyone would agree on, and that's very, very important as well. Now, this is particularly important because what we're trying to do here is provide a reliable basis for people to share the same expectations about autonomy, what it can do. And so moving towards sort of common vocabularies as well as test standards, test scenarios, etc., you'd think would be an obvious thing and be something we'd all be doing. But actually what we've identified is there's still a lot of work to be done. And it's not just a cultural or translational issue, because it happens even within a country. And a good example of things that we've identified, and again, this is not specific to maritime, you might find that a developer of a system, or a software developer, has a very different interpretation of what collision avoidance means to an expert mariner, for example, a master mariner. They'll have very different anticipations of that, and you'll see that evidence when they actually start demonstrating how their system operates. But we also see different interpretations of words, whether it's around autonomy, what do you mean by autonomy, or even levels of autonomy, what's a remote operator, and there's different definitions for that. And by the way, and again, this is not an issue that is specific to maritime, but also my understanding is there's even different interpretations of ship as well. As I said, I'm not a maritime expert, this is what I've been told. Now, one of our early activities, and we're actually already engaged with a country and potentially some other countries on this, is we're now going to start looking at developing a common approach to how we define test scenarios, so building the taxonomy for test scenarios, and also how those outputs are described as well. So that's going to be an early stage piece of work that we're doing in this. I've only got a few more slides. So infrastructure requirements, again, it's very interesting hearing about the challenges of infrastructure for energy and for emissions reduction, and we've got to look at infrastructure requirements in the same way. Obviously, your infrastructure requirements when you're out to sea will be different to when you are in a complex, high-value, high-risk environment, say in a smart port operation with a lot of third-party agents around. But nonetheless, you still need to be able to understand what are the required KPIs, what are the required standards around things like communications, resilient PNT, that's some of the work we're doing a lot of at the moment at MPL, around how you define situational awareness, and that's going to be very important, again, coming back to ground truthing, and data quality and management. And the last thing I'll mention on data quality and management, this is something that goes to the heart of what we do with measurement, is we look at how you build traceability and uncertainty into your data, so you understand all the way through the flow from actually what that sensor sees all the way through to what the outputs might be from a sort of fused data system as one example. But the key point there is you need to generate that trusted data, you need to have the right markers for it if you are to make or have confidence in the decisions being made by these autonomous systems. So that is something that we're very focused on and working very, very actively with others to understand better how we can move forward on data standards and data quality standards. 3 more slides. So this is something that we've been doing a lot of work in different areas of autonomy, is how and we work with other partners such as the Met Office on this, is how you link test environments. Because obviously one of the challenges of test environments is weather. It's a big issue, particularly for sensors, but also for other aspects of a system. And what we've been developing is this model, this sort of pyramid, this hierarchy model of different test environments. And by the way, I think the slides are going to be shared, so you might not be able to see that on a camera, that's all. But that will be, and I'm happy to talk to people afterwards about it. The point of this is if you have the test environments linked properly, then as you go through the test environments, you build more and more confidence in the system. One of the reasons why this is also important is when you start looking at operation is how are we going to maintain confidence in systems, particularly if you have updates or firmware upgrades, et cetera, or something different happens, the more have something replaced. It's how we start to look at things like formal verified models and how we use these different test environments for different reasons to mitigate risk or understand if the risk advisory has changed on a system. This is something we're doing a lot of work on at the moment. We're doing a lot of work for the Department for Transport on sensor performance for self-driving vehicles, and we're now translating that into, we've set up a testing scheme down in Plymouth which we hope to implement later this year, for maritime sensors. And what we're looking at here again is coming up with a really reliable characterization of how sensor performance changes in different environments. Again, weather's very important, but it's not the only thing. There's a whole range of other things that impact as well. And what we do is we come up with very accurate reference data, which we then, one of the things we're doing with that, we do several things. One of the things is we're turning that into much more simplified and more reliable specifications for sensors. Sorry if there's any sensor manufacturers in the room, but quite often this specification doesn't tell you what you need to know for an autonomous system, and this is something that we'll need to move forward on. So that's actually going to impact on standards. But other things we're also doing is actually we're actively now linking the reference data we have from there into virtual test environments, which I can talk about in a moment, and that helps with improving the sort of the sensor models that go into virtual testing, but also our ability to validate this as well. Finally, this is the last slide. Virtual test environments, again, a very important component in how you test autonomy, but also how you might assure operationally as well. For obvious reasons, virtual test environments has certain advantages. You don't have a high budgetary risk of sending lots of very expensive things out in the water and testing edge cases, which is not a good idea. But they need to be validated as well. So we've done an initial draft of requirements for the virtual test environment. Of course, then we were subsequently told there might be dual use in that, so I'm only able to share a very small amount of it, unfortunately. Some of you in this room have actually had to sign the waiver saying you won't share it on foreign servers, etc. But the virtual test environments present a lot of opportunities, but they're still being understood. So we've already been doing workshops both here and with other partners on understanding how we link that into other test environments and how we maximize benefit, but particularly how does that fit into a certification or assurance process, an official one? And another question is around how do you start to build standards around this, because you'll find that there'll be different people, different organizations creating virtual test environments. Some of those will be people who are designing systems, so they'll be marking their own homework. So how do we build in, and what are the standards we need for that? So I've come to the end of this. I'm sorry I've raced through that. I don't know how long I took. I didn't get a red card, did I?
No, definitely not.
Fantastic. So look, there's two more fantastic presentations after which hopefully we'll sort of build on and flesh out some of the stuff I've talked about as well. And looking forward to the panel talk afterwards. So thank you very much.
Super. Thank you very much indeed. Well done.